Yes, ma'am, I can.
Okay. Yeah, Harsha, any problem in surface area and volume so far?
No, ma'am. Ma'am, I have a doubt in one of the questions from triangles lesson.
Triangles, okay. Which exercise?
Ma'am, question number 14 of exercise 6.3.
6.3.
Yes, ma'am.
Question number 14. Okay, sides AB and AC and median. Right. The side AB and AC and then median AD, okay, are respectively proportional to this. Show that this triangle is similar to this triangle, okay. Right. Show that this is proportional, oh sorry, similar to this. Mhm. Yeah, I think in this question we were supposed to use the midpoint theorem, right? So we will do one construction here. Okay, first of all, what is given that AD and PM are actually median. So that means BD is equal to DC, right? This is given.
Yes, ma'am.
Okay, and QM is actually equal to MR, right? Now to prove that these two triangles ABC are actually similar to triangle PQR. So do one construction here. So we draw a line here which is actually parallel to AC. So draw D, I mean call it E, parallel to AC, right? And similarly in the other triangle, PQR, if I call it S. So and then you have your SM parallel to PR. This is the construction, right? So proof. Now if you look at this triangle ABC, right? So it's already given that D is the median. That means D is the midpoint of BC.
Yes, ma'am.
Yeah. Okay, so basically in triangle ABC, if I write that D is the midpoint of BC already given, and then DE is parallel to AC by construction. We have drawn it parallel. So if I use the converse of midpoint theorem here, so that means E is also the midpoint of AB.
Yes, ma'am.
So therefore E is the midpoint of side AB. We can write converse of midpoint theorem. Right. Mm, and then DE is half of AC. So that's a theorem, right? It's equal to half of its length.
Yes, ma'am.
Okay. So similarly in the other triangle, I'll get SM as half of PR. So you can write like similarly. So you don't have to repeat all these things. You can write SM is equal to half of side PR. Okay. So now we come to similarity part. So if I take AB upon PQ, okay, now if I take AB upon PQ, hmm, AB by P.
Ma'am, it's already given the proportional, right?
Oh yeah, it's given, right? Sorry. Yeah, so it's given that AB by PQ is AC by PR, and the third side. Okay, medians are proportional, so that means AD is proportional to PM. So this thing is given, right? Right. Okay. Mm, now in triangle, actually, which triangle I have to prove? Just one.
ABC and
ABC.
PQR.
Okay, ABC is similar to PQR. Okay. So ultimately, if I can show that, see here the problem is, Harsha, the two sides are already given, right? The AB side, right? And then the AC side. So the third side is not proportion. Actually, the median is proportion. So somehow we have to arrive at the third side, that BC upon QR is equal to BC by QR. Understood?
Yes, ma'am.
Okay. So first of all, we have to make use of this median. Mm, if I just convert this side, AB now can be written as twice of AE, right? And
Yes, ma'am.
similarly, PQ can now be written as twice of PS. So this becomes AC again, I can write twice of DE, and PR is again twice of SM, because I've already shown this, right? Is equal to AD by PM. Is it clear?
Yes, ma'am.
Okay. So this 2 cancels out. So now I have AE upon PS is equal to DE upon SM is equal to AD upon PM, right? So now look at these sides. Which are these sides? This is AE is this, right? And DE is this, and then AD is this. So basically this triangle is now similar to this triangle, understood?
Yes, ma'am.
So by SSS criteria, I have my triangle ADE is similar to triangle PMS, right? Okay, so therefore I can say that angles are also equal. So if I just call this one as my angle 1, let me use some other color. If this is my angle 1, right? And similarly here, this is my angle 3. So I can say that this also implies that angle 1 is equal to angle 3, right? And similarly, the other angles will also be equal. So this is 2, this is 4. So angle 2 is equal to angle 4. This I can say now, right? Oh, and
How will
hmm,
angle 2 be equal to angle 4?
I can say similarly, like if I do the construction on the right hand side and repeat the whole process, so that way I get 2 is equal to 4. So you can
Okay.
write similarly, right? Because one side I have I have done the construction. Okay. So similarly, I have got this. Now, if I can add the two, so I can get complete angle A, right? So just adding them. So angle 1 plus angle 2 is equal to angle 3 plus angle 4. So that gives me angle A is equal to angle P, which I actually need, right? Because two sides are also already in proportion. So middle angle was the requirement. Understood?
Yes, ma'am.
So I have got this, and okay, just mark it, give it some name if you want. So this is the result I've got. Now come back to your triangles. Okay. So if I just erase a little bit from here, can I erase this much?
Yes, ma'am.
Okay. So now I come back to my original triangles, ABC and PQR. So now in triangle ABC and triangle PQR. Now what do I have? The two sides are already given, that AB upon PQ is equal to AC upon PR. Proportion. Now the middle angle I have shown that angle A is equal to angle P, right? So I can say that by SAS criteria, now the triangle ABC is similar to triangle PQR, which I was supposed to.
Okay, ma'am.
Yeah, I think this similarly was actually important here because in place of similarly, you can also write like if we do the construction on the right hand side, so we get angle 2 is equal to angle 4. You can just write it in one line.
Done, ma'am. Thank you, ma'am.
Okay. Hamna is here. Yes, Hamna, can you hear me? So today I was actually thinking of starting circles. Is that okay?
Ma'am, the last question from surface areas and volumes we didn't do.
Okay, let's complete that. Exercise 13.3, right?
Yes,
Yes.
ma'am.
Hmm. Okay. So question number, what was the question?
Ma'am,
Yes, Sarah.
the surface area volume is only till 13.2. The 13.3 and all they are
No,
deleted.
13.3 is also coming because only the frustum is not coming in the syllabus. If you look
But
at
ma'am,
this, yes, Sarah.
but my mom was saying that we have only till that much only 13.2.
Okay, but if you look at the syllabus and even the formulas, the same formula are actually repeating, which are there in exercise 1 and 2. Might be on the difficulty basis, but we have already done, I think. Sarah, what about, sorry, Hamna, what about your school? Have they done the chapter?
No, ma'am, we didn't start the chapter.
Okay. So anyway, like one extra exercise we have done, and I think there's no new formula in it. So if it is omitted, we can omit it in the revision, right?
Yes, ma'am.
Okay. Fine, Sarah.
Yes, ma'am.
Okay, now look at question number 9. One last question was remaining. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, okay, which is 10 meter in diameter. So there is a circular tank in her field. So first of all, this is the circular tank. Let's say there's a tank, right, which is actually used to hold water. And its diameter is given. This is at 10 meter. Yeah, 10 meter, okay. And 2 meter deep. So height is also given 2 meter deep, right? A farmer connects a pipe. So basically, from some canal, some pipe is actually connected in this like this, right? To fill the water or something. So if I just draw the pipe separately, so the pipe will also be in the shape of a cylinder, clear?
Yes,
Right?
ma'am.
Okay. So the connects a pipe of internal diameter 20 centimeter. So this diameter is 20 centimeter, right? There's a difference in unit, 10 centimeter and meter. From a canal, which is 10, okay. If water flows through the pipe at the rate of this, in how much time will the tank be filled? I think because this exercise is slightly difficult, so might be because of that it is omitted. But anyway, Harsha, I think we have done. I'll just go through it again and we can skip it in the revision. I'll tell you. So we don't know the length of the pipe in this case, right?
Yes,
So,
ma'am.
okay. So if I call it like X or something, capital H, I can call it. So this height, actually, I don't know. If water flows through the pipe at the rate of this, in how much time will the tank be filled? See, I have only drawn a small portion of this pipe. The pipe is actually, it might be a long pipe, isn't it, Harsha?
Yes, ma'am.
Because this pipe is coming from the canal, understood? So I don't know its actual length. It might be a very long pipe. So just to, or even don't draw this side, leave it like this, right? So I cannot write H here because its length I don't know. So it's a pipe which is looking like this. So can I just assume that let H meter be the length of the pipe to fill the whole tank? Can I assume this? So let's say ki H meter of length of this pipe will actually fill the whole tank, right? So I've assumed that length to be H meter.
Ma'am, can't we find the length like how we found in the 8th question?
8th question. Just 1 minute. Let me go back to 8th question. Okay, water in a canal was this is showing this speed of this, how much area will it irrigate? Okay, this was the question. Okay. So how did we find it? By unitary method, right?
Yes, ma'am.
Okay, let us just try, right? So if we can say that length of pipe in, if water flows through the pipe at the rate of 3 kilometer per hour. So length of pipe in 1 hour is actually 3 kilometer, right? Am I right? But I think time is not given in this question. In question number 8, was it given?
Yes, ma'am, it was given.
So in this question, see, time is not given. So for unitary method, I should have some time here so that I can multiply this side and get the length. So let's do it this way. So if I say that length is H meter, so in that case, the volume of the tank will be same as the volume of the pipe, isn't it? For this particular length of the pipe, which is actually filling the tank. So volume of the tank will same as volume of pipe. Is it clear?
Yes, ma'am.
Okay. So let us first of all find out how much is volume of pipe. Right. Now it is in the shape of cylinder as we know. So the diameter is given, which is 20 centimeter. Okay, convert it in meter. So it becomes 20 divided by millicenti decimeter. That means 100, right? Now it is in meter. So it becomes 2 by 10 meter, right? So the radius will be divided by 2. So it only 1 by 10 meter. So that's the radius of the pipe. Okay. So the volume becomes volume of pipe. The formula is pi r square into h, and I have assumed it a small h. So leave it pi, and then radius is 1 upon 10 whole square, and h I don't know. So it is pi by 100 into h. Leave it like this. Now this volume is same as the volume of the okay, from 1 I'm writing. So from 1. Now volume of tank. The volume of tank is again, it's a cylinder, right?
Yes, ma'am.
Or you can separately find out first of all, then we can equate. Now come to volume of tank. So volume is again pi, now call it capital R square and call it capital H. Okay. So this is pi into radius will be 10 by 2 whole square, and height is given, that is 2 meter. So this is like 10 by 2 is 5 and 5 square is 25. 25 into 2 is 50. So this is 50 pi. Okay. So from 1, if I just equate now, so 50 pi is actually equal to this pi by 100 into h. So pi cancels out. That gives me h is equal to 500 meters, right? 30, right? Yeah, not 2, 30 now. So I can call it in kilometer also. So h is equal to 5 kilometer because 1000 meter is 1 kilometer. So 5 kilometer length of the pipe will be required to fill the whole tank. Understood? Now you have to tell the time actually in the question, that how much time, in how much time the tank will be filled, and the rate of flow is given, which is 3 kilometer per hour. Understood? So far, is it clear now?
Yes, ma'am.
Okay. So now we can say that,
Can you show the before page?
okay, so up till here, first of all, find out H, then we will proceed further.
Done, ma'am.
Okay. So now, rate of flow is given, right? Rate of flow is equal to 3 kilometer per hour. So what does it mean? That means, 3 kilometer volume of the water is flowing in 1 hour. Understood? It's like this. That if this length is, if this length is 3 kilometers, so that means this much volume of water is actually flowing in 1 hour. Understood? This means this. Got it?
Yes, ma'am.
Okay. So just now you can use the unitary method. So 3 kilometer, 3 kilometer, what do I say? Travel in pipe in like 1 hour. 3 kilometer of what I can say? 3 kilometer. I mean, I just want to equate something. So 3 kilometer is not the volume because it's kilometer means length. What will I call it? 3 kilometer of what? Travels in pipe in 1 hour. Okay, just leave it. Let me complete the question and think about it. So I can say that 1 kilometer of basically the water which is contained. I think you are getting an idea what I'm trying to say, right? That means this much volume of water which is falling in a length of 3 kilometer of pipe. So this much volume is actually transferring in 1 hour. Understood? So that means 1 kilometer will travel in what? 1 upon 3 hours, right? And similarly, now my length is 5 kilometer of the pipe. So the amount of water which is traveling, it will travel in 1 upon 3 into 5 hours. Is this clear? Is this idea clear? Right? Or now you can convert this hour into minutes if you wish. So this is 5 by 3. So 1 hour can be written as 60 minutes, right? And now if you just simplify it, so 3 into 2, 60, and 5 into 2 is 10. So it becomes 100 minutes. So in 100 minutes, the tank will be filled.
Can you explain that part again?
Yeah, okay. This much, right?
Yes, ma'am.
See, I'm just saying rate of flow means this thing. It's saying that rate of flow is 3 kilometer per hour. What does it mean? That, you know, if the pipe is empty, now try to understand, this is your pipe, right?
Yes, ma'am.
Okay. And if you like open water from this side, like water is actually filling the pipe. So in 1 hour, like how much length of the pipe will be filled? So in 1 hour, actually, let's say the pipe is filled from here to here. So basically this length will be 3 kilometers. It means this, that in 1 hour, 3 kilometer length of this pipe will be filled with water. Understood?
Okay, ma'am.
It means this thing. So 3 kilometer, I mean, this sentence is actually not correct, but the concept is actually clear. So I can just reframe the sentence here that in 1 hour, the water in the pipe travels a distance of 3 kilometer. It means this thing. So how can I reverse it? You can say that 3 kilometer distance is traveled by water. Can I call it like this? 3 kilometer distance is traveled by water in pipe in 1 hour. So 1 kilometer distance is traveled by water in 1 by 3 hours. Then 5 kilometer distance is traveled by water in this hour. Is this clear now? I hope sentence was actually a bit misleading earlier. Yes?
Yes, ma'am.
Yeah, I can call it distance, right? Because I'm using kilometer here. So it's actually distance. So 3 kilometer distance is traveled by water in pipe in 1 hour. So I hope now it is understood. So 1 kilometer,
But why are we using 5 kilometer?
because 5 kilometer, the rate was like in 1 hour, it was covering 3 kilometer, right? but my length of pipe is 5 kilometer because I want to fill a certain volume. So for filling up this much volume, the length of pipe which is required is actually 5 kilometer, right? And the rate which is given in the question is 3 kilometer, 3 kilometer per hour. So in 1 hour, it is traveling 3 kilometer, right? But my length is actually 5 kilometers. So I just want to know in how many hours this much amount of water will travel, this much length of the pipe will be covered by water. Is this clear?
Yes, ma'am.
Okay, so that is why I'm calculating for 5 kilometers. Hamna, can you hear me?
Yes, ma'am.
So I think I should not start the circle chapter then, because Sara is also saying that probability is coming in the exam and surface area and volume. So you people have done surface area and volume. So only probability is left, right?
Yes,
Okay.
yes, ma'am.
So today
Only
let us
quadratic equation is not coming.
is not coming. Yeah, but anyway, for your final exam it will be there. So we have already done it. So I think I should not start circles then. First of all, let me cover probability. Today I'm going to give you some extra questions from surface area and volume. And in the next class, I'm going to start the new chapter, okay? So now you will tell me the answer. I'll give you some calculations to do.
Ma'am, can you go back to the previous page once?
Mhm. Okay, I'm sharing some questions on the screen and then you start solving them. Just 1 minute.
Done, ma'am.
Okay, it's taking time, so I'm sending on your WhatsApp. But anyway, I'm also opening it here. Please start doing it. These questions were actually previously asked in CBSE also. Yeah, hello Harsha and Hamna.
Yes, ma'am.
Yeah, have you got a request for a breakout room? Actually, I just want to separate you and Sarah. I want to talk to Sarah because she has missed initial exercises. So till then you complete your questions. I'll give a revision to Sarah.
Okay, ma'am.
So please go to that breakout room if you have got a request. Hamna, you also please. And Sarah, you stay here.
Okay, ma'am.
Ma'am, I didn't get any request.
Okay, I think I'm not able to do it properly. 1 minute. Yeah. Sarah, can you hear me now?
Yes, ma'am.
Sorry, I just took me some time to do this. So till they are doing questions, so we can have a quick revision of first exercise. So I'll do 2 exercise with you, okay? As you are saying, third one is not coming.
Yeah.
Third one is actually a bit tough, right? I think might be because of that it's not coming. Okay, surface area and volume. So first of all, Sarah, you have to remember some formulas for this chapter, right? So
Yes,
one by
ma'am.
one, we will study the figures. So the first figure we have to study is called cube. Now try to, before formula, try to understand one thing. So we are going to study figures like cube, right? Cuboid, and we will study cylinder in this chapter, and then cone, okay? And then sphere and hemisphere. So let me just give you a brief introduction to each figure first of all, then I'll tell you formulas. So cube, you know, how does it look like, right?
Yes,
Cube,
ma'am.
cube means all the sides are equal. This is how cube looks like. And cuboid, it's like one face is actually rectangular. So all the 3 sides can be different also, or 2 can be same, 1 can be different, but all the sides are not equal. So this is a cuboid. Now a cylinder. So you have to study right circular cylinder, not just cylinder. Now what does it mean? Right circular cylinder means, so how does the cylinder is formed? For example, you have many coins, okay, 1 rupee coin. You have 100 coins. You are placing one coin over the other, like you are keeping like this, right? So ultimately the figure formed will be in the shape of a cylinder. Got it?
Yes,
So
ma'am.
this cylinder, so now the base, which is actually a coin. So coin is in the shape of a circle which has a center. So that means the top is also a center, the bottom is also a center. So the line which is joining center to center is called the height. Okay, and this is the radius of the circle, the base circle. So this angle should be 90 degrees. The height and radius should be at 90 degree. Such cylinder is called right circular cylinder, because it can be like this, like you're placing one coin like this, the next coin like this, the next coin like this. So they will not fall, but ultimately the cylinder which will be formed, it will look like this. Got it?
Yes, ma'am.
This is also a cylinder, but it's not a right circular cylinder. So only this type of cylinders you have to study. Similarly, in cone, you have to study right circular cone. Okay. Right circular cones means again the same thing. This is the base of the cone, which is actually a circle, and this is the cone. So the center of the circle and the height of the cone, they should be at 90 degrees. So this kind of cone you have to study. Otherwise, it can look like this also. This is also cone, but it's not a right circular cone, right? Okay. And then sphere,
Yes,
you
ma'am.
know, it's like a ball. And hemisphere means if you cut it into half, so it looks like this. So this is a hemisphere, like a bowl. Okay. Now there are 2 things: surface area, surface area. So we have to find how much is the area of the surface of these figures, right? So there are 2 terms. One is called the curved surface area and other is the total surface area, right? Okay. So if I look at this cone, Sarah, here, so the curved part is only this much, right? Like this is the curved part, right?
Yeah.
So that means if I'm just avoiding the base, I'm only calculating area of this curved, so I'll calculate curved surface area. And if I want total surface area, so I'll like first of all find this area, the curved one, and then I'll add the area of the base also. So that will give me total surface area. Clear? Similarly, in case of cylinder, like if I just avoid the area of the top and similarly the area of the bottom, and I only find this area, the curved one. So it will be curved surface area and the other is the total surface area. Understood? Okay. Now, in case of figures like this, because they are not curved, right? So
Yeah.
in place of curved, we use a term which is called lateral surface area. It also means the same thing. Like if I just avoid the top and I just avoid the bottom, the remaining faces, if I if I'm finding the area of the 4 faces, so it will be called as lateral surface area. Got it? And if I'm finding all the 6 faces, that means top and bottom also, so it will be total surface area. Understood? Okay.
Yes, ma'am.
Now in case of sphere is like curved from everywhere. So curved surface area or total surface area will be the same thing in this case. Okay.
Yes,
And
ma'am.
in case of hemisphere, so if I just cut it into half, now here the curved surface area will be different. It will be only this much, right? And if I also add the area of the top, that will be total surface area. Understood? So in first exercise, we only study about surface area, and the second exercise, we will study about the volume. So just note down formulas, and then we will come to exercise like next time. The first is cuboid. First figure is cuboid. So draw a diagram. This is how a cuboid looks like, right? So one side is length. This is length of this cuboid, right? This side is the breadth of this cuboid, and this it's the height of this cuboid. So lateral, or you can write curved so that you understand, but in this case it will be called as lateral because there is no curve here. Surface area. Okay, and then we write total surface area, and then we write its volume. Now lateral surface area, Sarah. So can you see the front face here, right?
Yeah.
This side is L and this side is H, right? This is a rectangle. I want to find its area. The formula is length into breadth. That means L into H. Understood? This
Yes,
is the
ma'am.
area. Similarly, the back side is same, exactly same. So 2 area I'll get 2 into L plus L into H, right? Front area and the back area. Is this clear?
Yes, ma'am.
Okay. Now if I take the right area, like this face, right side face. So basically this length is breadth and the height is H. Again, the area will be B into H, right? And similarly, I have one on the left also. So if I add, so again I get 2 into B into H. Is this clear?
Yes, ma'am.
Okay. So that means the lateral surface area becomes 2 into LH plus 2 into BH. Or you can take 2 common, you can write LH plus BH. That's the lateral surface area. That means avoiding the top and the bottom. Okay. Now total means I'm also adding the area of the top and the area of the bottom. Now you look at the bottom here. The bottom is this, right? This side is length and this side is breadth, right? So the area is length into breadth. Clear?
Yes, ma'am.
Like it's a rectangle. And similarly, area of the top is also length into breadth. So 1, 2 LB you are also adding. So total becomes 2 into LB is also added now. LB plus BH plus LH. That's the total surface area. Understood?
Yes, ma'am.
Okay. And the volume is length into breadth into height. That's the formula. Noted?
No, ma'am.
Okay. So in case you forget the formula, Sarah, like, in case you forget it, so at least you should be able to calculate it this way. You separate the faces, right? And then area of
Yes, ma'am.
rectangle, what is the area of the rectangle? That is length into breadth. So you can just multiply the two sides and find its area. Okay, next figure is cube. Now, how does a cube look like? A cube means the front face is a square, right? Every face is a square, right?
Yeah.
So basically every length is L. This is also L, this is also L, and this is also L, right? So everything will become L now. So like what will be this become? Lateral surface area. So okay, just convert it here. 2 into, right? H is also L. So L square plus this is also L square. So that becomes 4L square. Clear? So the formula is 4L square because everything is L, right?
Yes, ma'am.
See, look at the front face. This side is, sorry, it's a square, right? This is also L, this is also L. What is the formula? Length into length. So the area is L square. Clear? This area is L
Ma'am.
square. And then you have 4 equal faces. So formula becomes 4L square. Understood? Like front, back, left and right, 4 faces. And total surface area will be how much? Now you tell me. You also include the top and bottom.
6
6,
L
very good. Now 6 faces are there. So 6L square. Okay. And volume, again, every side is L. So it becomes L into L into L. So that becomes L cube, right? So the formula
Yes,
is
ma'am.
L cube.
Done, ma'am.
Okay, next. Third figure is again right circular cylinder. So at least formulas I'm giving you, then I can have some. I'll provide you the recording, Sarah,
Yeah.
and then we can discuss in some class. So this is the height of the cylinder, right? And this is the radius of the base or the top or the base, you can say, because top and base are same area. So you write curved surface area. In short, we can write it CSA also, right? So CSA, curved surface area, is 2 pi r into h. You know what is the circumference of the circle? It's 2 pi r, right?
Yeah.
And then you multiply this with height. So that becomes 2 pi r h. So that gives you the curved surface area. Okay. Now total surface area, I call it TSA. Total surface area means now the curved surface area, right? Plus one top. Top is what? A circle. What is the area of the circle? Pi r square. Right, Sarah?
Yes.
And then one bottom also you have, which is again a circle of same radius. So its area is also pi r square. So what will be the total area? So 2 pi r h, right? Plus 2 pi r square. Understood? So 2 pi r h plus 2 pi r square. That's the total surface area of the cylinder. Now the volume is 1 upon 3 pi r square h. So now remember, pi r square h is actually the volume of the cylinder, right? Oh, wait. Sorry. I have written wrong. I was just saying this is the volume of the cone. Sorry. This is pi r square h. In the cone, we will see it's 1/3 of this volume. So cylinder is pi r. Pi r square h means again the same thing. This is the base, right, Sarah? Whose area is pi r square, right? Now you
Yes, ma'am.
multiply this area with the height. So that gives you the complete volume of the cylinder. Got it? So pi r square, when it is multiplied with height, so this becomes the volume of the cylinder. Fine?
Yes, ma'am.
Okay. Now next come to cone. So I'm just writing here only TSA and volume. So it's right circular cone. It looks like this. There's a base and then this is cone. So the radius of the base is again small r I'm taking, and this is height of the cone. Okay, now only the curved surface area, it is pi r L. Now please note what is this L. L is this side, which is called the slant height, right? So here you will write L is the slant height. And please mark it in figure what is L. So L is nothing, like this side is also L, this side is also L. So from Pythagoras theorem, I can say because it's a right circular cone, so this angle is 90 degree, right? This is H, this is R, this is L, right, Sarah? Because
Yes,
this angle is 90 degree. So from Pythagoras theorem, L square is actually H square plus R square. That means L is under root of H square plus R square. So that's how you find the slant height, whose formula is under root H square plus R square. So this is an additional thing in case of cone. In some questions, you are supposed to find slant height also. Okay, now total surface area means, Sarah, this is pi RL is the curved surface area. Okay, and then you add the area of the base, which is a circle whose area is pi r square. So this becomes the total surface area of the cone. And volume is 1/3 of the volume of the cylinder. Please remember this. So 1/3 pi r square h. Pi r square h is the volume of the cylinder. It is 1/3 of that volume. Oh, it's time for my next class. Now please quickly write down 2 more formula.
I'm done. Yeah.
Okay. Next is sphere. Sphere, you know, it looks like this, whose only radius we know. So the curved surface area is 4 times the area of the circle, right? 4 pi r square. Okay. And total surface area is also same because it's same from everywhere. And then volume you write. So volume is 4 by 3 pi r cube. Okay. Now you come to hemisphere. So hemisphere is like just half of it. Okay. Now curved surface area will be half of the sphere. So it is 2 pi r square, right? But the total surface area, it will be curved surface area, right? 2 pi r square plus area of the top, which is pi r square. So that becomes actually 3 pi r square. Understood? So that's the total surface area of the hemisphere. And volume is again just half of the volume of the sphere. So it is 2 by 3 pi r cube. That's it. So these 5 shapes you have to remember. 6, I mean. Okay, Sarah, now please just go through the formula and then we will take up some other time. Okay.
Okay, ma'am.
Okay
Thank you,
then.
ma'am.
Bye. Yes. Hello, Jaslyn. Can you hear me?
Yes, ma'am.
Okay. So let's wait for just 1-2 minutes.
Okay, ma'am.
Other people will also be joining. Then I'll start.